So what is a polynomial? All right, so a polynomial is the sum or difference of monomials. And monomials are each one of these things. So x cubed is a monomial, 3x is a monomial, 2x squared is a monomial, okay? So it's a sum and difference of monomials. Now, within those monomials, you have to have, come on, right? You have to have real number coefficients. So you can't have imaginaries. So if you see an imaginary in there, it's a problem. And you have to have whole number exponents. So no imaginaries. Let's go red. No i's. And you can't have variables in the exponent. So no variables in the exponent. You can have variables, they just can't be in the exponent. So that's what we've got going on here. So the first thing we're trying to do is identify, hey, is this a polynomial or is it not a polynomial? So we look at each one of these. The first question says, hey, is it a polynomial? And so we're looking for sum and difference of monomials. We do have sum of monomials. We have whole number coefficients. There's a 1 here, and you've got a 3 here. So it checks that box. You have a 3 as an exponent and a 1 as an exponent. So it checks that box. Check this box. So 1a is a polynomial. So f of x equals x cubed plus 3x is a monomial. I'm sorry, is a polynomial. So we just got to check. Does it have real number coefficients? Does it have whole number exponents? And as long as it has those things, we're good to go. All right. So we have a problem here on B. We've got this x hanging out right there. Let's go with red, because red means stop. Okay? That's bad. If you have a variable as an exponent, you do not have a polynomial. So no. Do not have a polynomial on this one. All right, as we move on to C, I just gotta find my right. Do you have real number coefficients? Yes, we do. 6, -2, 1, those are all real numbers. Okay? And eraser. Do you have whole number exponents? So the question becomes, is -1, is -1 a whole number? Yes, it is. Okay? It is a whole number. So, yes. We do have a polynomial there. You can have a negative exponent. All right, down to D. Okay. Is this a real number? Yes, it is. It is real. Is pi a real number? Yes, it is. It is real. Is square root 2 real? Yes, it is. So once again, we fit the category because all the exponents are either a 1 or a 2. So we're good to go there. So we have 4 different examples. We got a no there because the x as an exponent is not a whole number. So that is how do we tell if it is or is not a polynomial. All right. So let's move on. We'll talk about this. We're going to vocab these. We're going to just define these and see, what are these things down here at the bottom. So a polynomial in standard form is when the terms decrease by exponent. So when you look at your exponents, you've got a 3 here and a 1 there. So we're going to do it based on decreasing exponent value. So the highest exponent goes first, and then we'll go down from there. The degree is the highest exponent, or the biggest exponent. Trying to write slow so it writes clearly. The highest exponent is the degree. We're going to talk a lot about the degree. The degree tells us information about the polynomial, but it's the highest exponent. The leading coefficient is the number with the degree term. So if you look at example C up here, the 4 is the degree. Excuse me. 4 is the degree, making the 6 the leading coefficient. So those two terms, the degree and the leading coefficient, will be together. And the constant. Constant is the number without a variable. And so, a variable, the letters, variable means to vary. So if I take a number and plug it into that variable, then that term's number can change. If we just have the number with no variable, then that number can't change, and therefore it's constantly the same thing. All right, so let's move and look at some of this stuff. Write in standard form, then identify the degree, leading coefficient, and the constant. We should still be on page 1. So what they're saying is that this information, this is not in order. Okay, so when you look at it, you'll see that the 2x squared is in the front, 3x to the 4th is in the middle. And so the highest exponent is not up in the front of the problem. So with standard form, we take the highest exponent and the coefficient that is with it. That entire term gets put in the front of the problem. So negative 3x to the 4th will be the first thing in the problem. And then we look for the next highest exponent. And the next highest exponent is going to be, I got to move this a little bit. The next highest exponent is going to be this plus 12x to the 3rd. Plus 12x to the 3rd. And we keep going down. So we can find the next highest exponent, which is 2x squared. That's positive 2x squared, so it's plus 2x squared. And finally, the negative 4 comes over here on the end. So that polynomial in standard form is negative 3x to the fourth plus 12x to the third plus 2x squared minus 4. Please note that the signs traveled with their number. All right, so that's standard form. Let's talk about degree. The degree is the highest exponent. So I have exponents of 4, 3, 2, and there isn't one on the 4. So this 4 right there becomes the degree. And so our degree is 4. It's the highest exponent in the polynomial. The leading coefficient is the number with the degree term. So what's the coefficient of that term? It is the negative 3. That is the leading coefficient. Leading coefficient in the degree will be on the same term, or be on the same x. Well, that's disappointing. And finally, the constant of this problem. Constant is the number without a variable. So is there a number in this problem without a variable? Yes, there is. Negative 4. So those are the types of questions. That's a lot of the types of questions you're going to see in this unit. So just basically, it's an interpretation of an equation for you. All right, so this is one term. Oh, come on, one term. And in the next one, here, that has 2 terms. Come on, stop moving. 2 terms. This also has 2 terms. This has 3 terms. 1, 2, 3. This also has 3 terms. And the last one has 4 terms. So 1, 2, 3, 4 different terms make up the addition and the subtraction of that polynomial. We can call these things by their name. So a few minutes ago, you guys told me trinomial. So I think you're pretty astute to know that something with 3 terms is called a trinomial. Trinomial. This is also a trinomial because it has 3 terms. I think y'all got that. I think you understand that. Well, I think you were struggling a little bit with the 2-term polynomial, but that's just a binomial, and I'm positive you guys have heard that before. And I think you could probably even tell me that these first ones are monomials. I get all that in there? Yes. The last one does not have a special name. Anything beyond a trinomial is just called a polynomial. So this last one is just a poly. So we have monomials, binomials, trinomials, and polynomials, and they're attached to these terms that are to the left of them. All right. So then we get into calling them by name. Now, that's based on the degree, and the degree is the highest exponent in the problem, in the polynomial. So when we look at these, all right, let's see what. All right, so to name a polynomial by its degree, you find out what its degree is. So our degree on this first problem is 0, and we call that constant. Degree on the second one is 1. We call that linear. The degree on the third one is 2. We call that quadratic. Wrong color. Get the arrow. Degree on this fourth one is 3. We call that cubic. And then I'm going to skip and go to this one because it's different. The degree on this one is 4, which is called quartic. So that's classifying polynomials by its degree. So just to finish off the chart, because there's some duplicates, this has a degree of 2, called quadratic. And this last one has a degree of 3, which is also cubic. So on page 2, we go back and look at operations of polynomials. This is something that you and I have done already. We did this back in Unit 1 with quadratics, adding and subtracting. So when you're adding, you're combining like terms, and you make sure you write it in standard form. So you want to look throughout the entire polynomial. Standard form says highest exponent first. So here's your highest exponent. Do you have any other? Is anything else a cubic? No. So 2x cubed comes first. So we have 2x cubed. Then you're looking for the next highest exponent, which will be 2x squared. Are there any other x squared terms? No. So 2x squared gets written down next to that without adding anything to it. And you can't add 2x cubed and 2x squared because they're not like terms. So you move on to your first degree terms. Here's a 7x, here's a negative 8x. So you do have two terms that are both x to the first powers, so we can add those together or combine them. And so that's going to give us negative x. And then finally we have negative 4 and a positive 1 that will combine to give us negative 3. All right, with subtraction, just like I told you back in complex numbers, we want to make sure we distribute the negative. And so what that means is you're going to take the negative that's in the middle and give it to everything that's behind it. Don't distribute it forward, only distribute it behind the subtraction sign. And then at that point, you're just adding. This is adding. Okay, that's the same directions that are underneath the adding. So find like terms. Find the highest degree, highest exponent is going to be negative 4x squared, negative 3x squared, for a total of negative 7x squared. Kind of move along, look for the next exponent, which will be x to the first power. I have a negative x and a negative x. No, they don't cancel each other. They give you negative 2x. Don't change the exponent. You are doing addition. Oops, I kind of erased too much there, guys. So I gotta get my signs back in there. All right. So then I've got a 7 and a negative 12. And together, 7 minus 12 is negative 5. And that's the answer to the subtraction. It has been combined, and it's in standard form, which says the exponent decreases. We start with the highest of 2, and we go down from there. All right. So in multiplication, you want to make sure you distribute. Let's distribute every term from one into every term of the other. So on this G problem, we're going to take the negative 3 and distribute it to 3 different terms. So that will be negative 12x to the 3rd power, because we add exponents when we're multiplying. Negative 3x squared and positive 27x. Now, what you're going to see me do next is different. I don't know if your teacher did this last year with you or not, but I'm going to group my like terms as I'm doing the problem. So I'm going to take the 2, and I'm going to multiply it. So 2 times 4x squared is 8x squared. So I'm lining up my like terms right away so I can see what it is I need to combine. 2 times x is 2x, and 2 times negative 9 is negative 18. You'll notice that negative 18 doesn't have a like term, so just put it at the back. Finish that up. It's in standard form. Negative 12 x to the 3rd power plus, I'm sorry guys, plus 5x squared. Don't change the exponents now. Okay, we're no longer multiplying, we're combining. Plus 29x minus 18, and that is G. That is the multiplied version of G. All right, looking at H. The 2 here means that there are 2 of them. So we have to write 2x plus 5 times 2x plus 5. And then we're into foiling. Okay, basically what you're going to have here as a result is a perfect square trinomial. So foiling that, 2x times 2x right here, it's 4x squared. 2x times 5 is 10x. And then I'm going to get rid of those. And I'm going to do it on the bottom. 5 times 2x is another 10x. And 5 times 5 is 25. Total that up. 4x squared plus 20x plus 25.